Now we're going to learn how to do what's called a running fix. So, as I explained earlier, a fix is when you get your position based off of 3 separate lines of bearings, lines of position, and where they all intersect, whether they be lines or arcs, is your true position. Now, 3 LOPs implies 3 different nav aids that you can use to find your position. What if that's not available? What if you don't have that? What if you only have one reliable object that you can locate and identify and use for your LOPs? What do you do then? You can't just not do anything. What you do is called a running fix. It's when you base your LOPs off of a single point multiple times over a certain period of time and compare those shots between one another to then determine what your position should be. And while a running fix isn't necessarily as accurate as a normal round of bearing or a bearing in range or whatever you may get, it's still definitely better than nothing. So I've set up a problem here. Let's say you're at this position at 0900. You're headed along this line on a course of 240 true, headed that way, at a speed of 12 knots. And there, as you can see, there are no lighted objects around here anywhere, but there is, I'll zoom in so you can read better, there is a flagstaff here. There's a spire and a tank, but let's assume this flagstaff is the only thing that you can clearly identify and see without a problem, right there. So that's what you're going to use to take your fixes now, because it's the only option you have. So let's say at 0910, you take a bearing of the flagstaff and you get a relative bearing of 310. It bears 310. So you take out your triangle. You measure 310 right there. There you go. Make sure your window is in position. You shift this down until you get it right along your flagstaff. You can see it's right in position now. And then you draw a line there. That's shifted a little at the end, but it's fine. So that's your line of position. You know that at 0910, you were here, somewhere along this line, without like a shadow of a doubt. Let's say at 0922, you take another bearing of the flagstaff, and it bears 005. So now it's northeast of you. You measure out 005. So I haven't done an extreme angle like that yet. With you, it can get kind of difficult when it's at that height, because you can see how finicky it gets at that point. But there's an angle of 005. You take your triangle, bring it down. There you go. And you draw a new LOP. Okay. So at 0910, you were here. Let's be clear, the angles now no longer matter. All you know is that you were along this line at 0910 and you were along this line at 0922. What this bore doesn't matter anymore. Those were your bearings. This also doesn't really matter to you anymore because you're already all the way over here now. But you can still use this to find this more precisely, because you don't know. You could be right here, you could be here, you could be right up against the water here. You're not sure. So the way a running fix works is you're essentially applying the principles of a dead reckoning position, using it to get your fix. This happened over an interval of 12 minutes, just like you're predicting ahead 6 minutes in this case. So in both situations, You need to know how far will I go in a certain amount of time at whatever speed I've been given. Here we've been given a speed of 12 knots. Okay, how far do you go in 12 minutes at 12 knots? You don't need to do any calculations for that because you already know the 6-minute rule. You know, because of the 6-minute rule, in 12 minutes you'll go, in 6 minutes you'll go 1.2 miles, right? Because that's 1/10 of 12. Okay, well 12 minutes is 2 units of 6, so you'll go 2.4 miles, right? It's not that complicated. It's just you need to have that system in your head all the time so you don't forget it. So you know that wherever you were along this track line, you are now 2.4 miles this way. And even if you started here, you were 2.4 miles over here. If you started here, you were 2.4 miles over here. Because no matter where you were still going in this track line at on a course of 240. So they would all be in the same direction away from each other. Meaning you can measure out 2.4 miles and you can plot it anywhere along your original line of bearing, as long as it follows the original track line of 2.4 miles, or of 240. So if you put it right on where your LOP intersects your track line, that's a position where you've already got a course of 240 measured out without having to do any extra plotting. So you can use that, mark it right there. There's where it ends. And then you can draw a new line parallel to this one all the way over there where it intersected your track line. So you measure this out. Slide this down your track line until you get to that tick mark you made and draw a new line. And this is your LOP based off of this one that you've advanced to 0922. So this is your 0922 LOP, and this is also a 0922 LOP. They both intersect right here. So I said that you shouldn't rely on a fix unless it uses 3 lines of position. But when you are working on a running fix, you're already in a situation where you don't have enough nav aids to be able to get 3 lines of position automatically. So in that case, you have no other option. You have to rely on what you can get. So here you have a 2 LOP fix for 0922, and it shows you pretty close to your track line. It's the best you can do, so you should be satisfied with this. You can't get more lines of position right now just because there aren't other things available. There's the Spire, but I said in this case, you can't use it. Only the Flagstaff is visible in this situation. So let's try that again. For this one, I kind of planned things out in advance, so I was able to get it more realistic, but I'm going to make up the numbers now for this. So what should I use? Yeah, we'll just use Little Gull Island. So let's say you're on track over here. You're on this track line. Doesn't even matter what course you're moving or where you started. You just know that you're going this way. And let's give a new speed of 10 knots. So you're going 10 knots along this track line up this way. And let's say at 10:30, Little Gull Island bore 355. So you measure out 355 right there. And then you take your second triangle, place it up there so that you can slide your first triangle along it. Bring it to Little Gull Island right there. And you draw your LOP. So at 0, I think I said 0, 1000. At 0, 1000, you were along this track line. You were along this LOP, and you were following this track line. Let's say at 0, 10, 15, at 0, 10, 15, it now bore 3, 5, or 340. So now you measure out a new angle of 340 right there. Bring it over. Let's do 330. It's just going to make the math be a little more realistic. Like I said, I'm making these all up as I go. 330. Sorry. Okay. Now you plot your line, your LOP right here, and it passes through here. So this was your LOP at 0, 1000. This is your new LOP at 0, 10, 15, right there. Now you've got to advance your 0, 1000 LOP to your 0, 10, 15 LOP. So the difference in time is obviously 15 minutes. How far did you go in 15 minutes at 10 knots? Well, let's see. Speed times time, 10 times 15 divided by 60, because 60D, you get 2.5. So you moved 2.5 miles in those 15 minutes. Come to your distance scale. Measure out 2.5 miles. You can see that I made this up because the numbers don't perfectly work, but that's actually, okay, this is a little extreme. Let's say instead of 10:15, it was 10:05. Yeah, not 15 minutes, because 15 minutes would be way too far off course. Let's say 10:05. So now you only did this in 5 minutes. 5 times 15, or no, 5 times 10 divided by 60. You went 0.8 miles. So you measure out 0.8 miles, 0.833, but you can't work with a 0.33. You plot it along your track line, starting from your original 1000 LOP, moving towards your new LOP. But you can see in this case, you didn't get all the way over there. You make a little tick mark there. Then you set your triangle parallel to your original LOP. Shift it along your track line to your new one, or to your tick mark. Then you draw a new line. And that is your new advanced 01005 LOP alongside your original 01005 LOP. And you can see they both intersect right here. So you can treat that as your 01005 fix. Look at that. In this case, your 1005 fix is substantially nearly half a mile away from your track line. That doesn't mean you did any of your plotting incorrectly. That means that your ship is off course. Maybe there's a current, maybe there's a wind. It's possible you also plotted incorrectly, so you always want to double check your work to confirm. But if you've double, triple checked, and this is where you keep getting your answer, that means that your ship is off course from where it should be. And that will get into what your next steps are.